Hi guys, so we are continuing the GATE 2017 paper. Next question was the major product formed in the following reaction sequence. So here an acyl chloride reacts with NaN3 in aqueous toluene, then second heating condition, then benzyl alcohol. So what will be the product? As we know here that this is an acyl chloride plus this is a nucleophile. So here substitution via nucleophilic addition elimination will take place. That is, the nucleophile will attack this electrophilic center and Cl will remove. So the product will be this. The resonance structure, this is now if it is heated in second condition, then what will happen? This is an acyl azide, so this will undergo a rearrangement reaction called Cartesian rearrangement. What will happen? This group will migrate here and N2 will eliminate, minus N2. So an isocyanate intermediate, an alkyl isocyanate intermediate will form. This carbon, this will bonded to N double bond C double bond O. Now this alkyl isocyanate, if it react with benzyl alcohol, so pH H, now H plus H minus, this will be removed and this proton will be taken by this nitrogen. So this will be the product. Next question, the structure of the major products W and X in the following reaction sequence. So this is pyridine and this is the PAR acid. So pyridine reacts with PAR acid to form, this is a known reaction, pyridine N oxide will formed. So pyridine, it has one lone pair of electron, it will react with this PAR acid to form the pyridine N oxide. Now it react with benzyl bromide, as this is an alkyl halide, it is an electrophilic center and this is a nucleophile, so it will attack and simple SN2 reaction will take place. So the product will be this. Now if it is treated with a base NaOH, then here this proton is quite acidic because of this strong electronegativity of oxygen. So OH minus will take this proton and the corresponding conjugate base will form. Now it will cleave to produce the pyridine plus this will convert to benzaldehyde, PHCHO. As for your information, this is a good method to produce alkyl halide to aldehyde. So this will be the product, pyridine and benzaldehyde. Next question is from NMR. The spectroscopic data for an organic compound with molecular formula C10H12O2 are given below. That is the IR spectra 1750 cm inverse, and the 1H NMR spectral data are given. So as we see here, that 1750 means a carbonyl group is there, and secondly 1H NMR data is delta equal to 7.3 multiplied 5H. Multiplied 5H 7.3, these are aromatic proton. So 5H means there will be a phenyl group with the mono substitution. So there will be a phenyl group. Now 5.85 1H, that means the strong electronegative atom will be connected with the carbon, and 1H with J equal to and it is a quartet. Quartet means there will be a CH-CH3 group. CH-CH3 group will be there, and here J equal to 7.2, and another data 1.5 J equal to 7.2, and it is 3H. So there will be a CH-CH3 group, and another is 2.05, it is singlet and 3H, so an isolated methyl group will be there. Now we'll draw the structure of this for methyl 2-phenyl propionate. Methyl 2-phenyl propionate, that means propionic acid ester methyl 2-phenyl. 2-phenyl means phenyl group at 2, carbon 2, this is 1, 2, 3, so CH, CH3, this is 2-phenyl, methyl 2-phenyl propionate, this is A. Now B, 1-methyl ethyl acetate. Acetate means acetic acid ester. 1-phenyl ethyl. 1-phenyl ethyls means CH, CH3, PH. This is 1, 2, so 1-phenyl ethyl group is there, and this is acetate ester. Now 2-phenyl ethyl acetate. 2-phenyl means phenyl will be here. So CH3, C double bond O, O, CH2, CH2, PH. And this is A, this is B, C, and the D, methyl 3-phenyl propionate. Means 3-phenyl means this is 2-phenyl, 3-phenyl, PH, CH2, CH2, C double bond O, CH3. This is D. So now what will be the answer? As we see here, that the groups will be CH, CH3, CH3 and phenyl. Now in D, CH2, CH2 group is there, so this will not happen. As well as in C, CH2, CH2 is there, so this will not happen. Now between these two, here CH, CH3 group is there, and here also CH, CH3 group is there, phenyl and CH3. Now what will be the answer? Here a keto group in both this compound, so this 1750, this is for keto group. And now as we see here that this 1H signal appear at 5.85, that means a strong electronegative atom is connected with this CH group. So this will be our answer, because here this CH will not appear at such downped. So our answer will be B. So guys, if you have any doubt regarding this video, please let me know in comment box. Next question, this is also from NMR. The 13C NMR spectrum of acetone D6 has a signal at 30 ppm as a septate the intensity ratio of this septate. So acetone D6 is CD3 CD3. So as you can see here that a plane will pass from through this axis. So this 2 CH3 group will appear on the as a single signal. So and this carbon is sp3 hybridized, so this will appear at 30 ppm. Now this carbon signal will be splitted by this 3 deuterium. Deuterium has spin quantum number is equal to 1, half plus half, that means 1. So it will split one signal into 2s plus 1 equal to 2 into 1 plus 1 into a triplet. Now 3 deuterium are there, so the singlet signal for carbon, this carbon will be a septate. Now the intensity ratio can be determined in this way. Let's say this is the carbon signal. It will be splitted as a triplet with one deuterium. Now the next deuterium will split this 3 signal each into a triplet. So this will be again a triplet, and this will be a triplet. This is the second deuterium, and the third deuterium, it will split each signal into a triplet. So sorry, again I am telling that this singlet will be splitted into a triplet, this doublet into a triplet, this triplet into a triplet, this doublet into a triplet, this singlet into a triplet. So this will be the intensity ratio. So this is 1 is to 3 is to 6 is to 7 is to 6 is to 3 is to 1. So as you can see here, this is 1 is to 3 is to 6 is to 7 is to 6 is to 3 is to 1. So B will be the answer. Next question. Hydration of fumaric acid gives the malic acid. This is fumaric acid, so which reacts with H2O to give the malic acid. Now here the question is that if H2O adds specifically from A phase or B phase, then which statement is correct? That means A phase is from above the plane and B phase is from below the plane. So we will add this from above the plane and below the plane, and we will see the configuration of this malic acid. So this is fumaric acid. Now this is A phase, so above the plane. If H2O comes from above the plane, then here is a hydrogen. Let's say here OH and here H will add from above the plane, then COOH is in plane and OH will come above the plane, and this hydrogen will go below the plane. Here it will be COOH, H. Now we have to determine the stoichiochemistry of this chiral center. So according to CIP rule, the priority sequence of this 4 group is, this will be 1 as it is oxygen, then here is a carbon CH2, here is C which is attached to oxygen, so this will be 2 and this is 3. Now our I is rotating from 1 to 2 to 3 in anti-clockwise direction, so this is S. So if this is Fs, attack from Fs. So if attack from Fs, this is Fs. So if attack from Fs will occur, then the configuration will be S. This is the true statement. So attack from Fs gives the S isomer. This will be the answer. Now if we'll see if attack from B phase will occur, then what will be the product? Attack from B phase means here which will add, here hydrogen will add from below the plane. So COOH, which will be below the plane, hydrogen will be above the plane, and here this hydrogen will be below the plane. Now this chiral center, this is 1, 2, 3. Now hydrogen is above the plane, so our eye is rotating 1, 2, 3. That means anti-clockwise direction, but the configuration is S. But as the hydrogen is above the plane, now if we keep the hydrogen below the plane, then the configuration will be R. So it has the configuration R. So the statement A is correct. So guys, if you have any doubt regarding this video, please let me know in comment box, and to get such interesting video, subscribe my channel. Thank you. Have a good day.